Good evening everybody. Today in this video we're gonna see a quick tutorial about uh, implementing CI/CD pipelines for a PHP Laravel application. So in this video we're gonna follow my blog tutorial on my website. So the first thing I wanna do before diving into the technical stuff, I wanna show you the application we're gonna work on. So I have some videos for it. So basically it's a TV shows platform, so clients can watch TV shows for monthly subscriptions. It has also the actors support in it, so people can see actors of the movies. They can also manage their profiles and manage their subscriptions, and of course watch the TV shows. As you see, it has also an administrator panel, so administrator can manage the platform resources and publish new episodes, see statistics, and add new shows, of course. So this is the application we're gonna work on in this tutorial. So the first thing we're gonna do is to analyze the requirements of this application. So the first thing in this application, in order to make it work, you need a database. You need a MySQL database, and you need a volumes to store the images and the videos, and we need a web server. So the web server will be required in order to deploy our application. So it's not required when we developing the application, but it's going to be required when we deploy it. So in this case we're gonna need it. We have also an SMTP server, but we're not gonna dive into that for this tutorial because it's not related to the deployment more than the configuration of your application. So now we're gonna analyze the application's dockerization needs after we specified them. So for this, I have a diagram in here in my blog which describing the architecture of our application. So the first thing, we have 3 containers. The first container is the web server container. It would be an Nginx web server, and we have a PHP Laravel container that contain our application, and we have a MySQL database in another container. And you see these 3 containers are connected together using a virtual network. So this virtual network is required so they can communicate with each other. So the Nginx web server will proxy the request from the client to our PHP Laravel application, and this application will be connected to MySQL database to store data and obtain it. We have also 2 volumes. The first volume will be for the MySQL database to store data files, and the second one for static files like the images and the videos of the shows. This volume will be shared between the PHP Laravel application to store static files and the Nginx web server to serve them to the client. So these volumes are very important to keep our data safe and not to be removed when we remove the containers, so they can stand alone without the containers if they are shut down. So this is the architecture we're gonna try to implement, as you see. So the first thing in the implementation, we're gonna create a Docker Compose file. So this is the code base of my application. So let's create a Docker Compose file. So the first thing we're gonna declare is the networks. So we're gonna create a virtual network as we agreed in the architecture we saw earlier. We're gonna also create 2 volumes, the first one for the database and the second one for static file storing. And here we have our web server, as you see. We're gonna copy this. So this basically will create a container which is obtained from the Nginx image. It has some configurations like the volumes. So this is basically we binding our folders where we store our static files like avatars, thumbnails for the videos, or the posters for the TV shows. We have also this public folder that will be binded from our code base inside the container. So container will need it to serve the static files that we are using. And we have also this Nginx configuration that we're gonna create, and we're gonna bind it into the etc/nginx/conf.d. So basically this is the default location for the Nginx configuration file. So for the configuration file, we have this configuration. So let me create the Nginx file. It must be inside the Docker folder. So basically this is how I organize my code base. So inside the Docker folder, we have an Nginx folder, and inside that Nginx folder, we're going to name it nginx.conf. So in this file, we're gonna configure Nginx to work with our PHP Laravel application. So we're going to see that we listen to port 80, which is the HTTP port. So we're gonna serve the .php files using the backend application, or the backend container that our application lives in it. And we're gonna also serve the static files from the volume associated to the Nginx container. So this is basically all done with the Nginx. So now we're gonna configure the other container, which is the MySQL database. So we can add this to the Docker Compose file. So this basically creates a container from the MySQL image. It has some configurations like the database, user, password. I don't think we need this user and password. We can use the root password when we connect into the database, so we don't need that. And also we can bind ports in here. We can bind the port 3306 with the same port, so we can access our database remotely. And also for the web server, we can bind port 80 with a port that must be specified in the environment variables. So in my case, in my environment variable, I have 8888. So you can choose any port that is open in your computer. For my case, this is the port I want. So now let's go to the next container, which will be the PHP Laravel backend container. We can copy this and put it in here. So we go in to build this container not from an image like the previous ones, but we go in to build it from a Docker file that we're gonna create now. So the Docker file will be located in this folder. Let me create it. Docker file. So in this Docker file, we're gonna specify how we're gonna build our application for the production environment. So I have already the contents of the file in my blog. You can copy it and use it as a template for your application. You might have a different needs than I have in my application, but you can use the same template and integrate it with your application. In my case, that was my needs. It's not necessary to be yours as well. So here basically we're gonna install some dependencies. We're gonna start from this PHP image, which is ready for production. We're gonna install some libraries. In this case, these libraries are used to manipulate images because my application needs them. We're gonna install also Node.js and npm to build the CSS and JavaScript files. We're gonna also install the MySQL PDO so we can connect to the database, and we're gonna also install the Composer, which is the package manager of PHP. So we're gonna change the work directory, and we're gonna copy all of our source files we have in the code base into that container. We're gonna grant the permission for that for the www.data user, and we're gonna switch to it. Then we're gonna install the dependencies of the composer, and we're gonna install the npm packages. We're gonna build the resources files like the JS files, CSS files using npm with this command. So this is basically the command that we use in Laravel to build these files. We're gonna expose the port 9000 because the PHP fpm image or package needs run on this port, and then we're gonna run this command to start our application. So this is basically our Docker file that runs our application, and we're gonna use it in the Docker Compose to build our backend container. This backend container also bind the same folders like we saw in the Nginx container with the storage or the volume we created in here. So our static files will be saved will be saved there. We have also a php.ini file, which is some configuration to run PHP. So basically we can get this file. We get this file from this folder, I think, php.ini, and we're gonna bind it to this path, which is the place where PHP puts its configuration file. And if I remember, I needed to change this configuration because in my application I need the upload max file size to be at least 100 megabytes. The same thing for the post max size, because in my application the client might upload a large videos. So for that I needed to change this configuration because the default only, I think, 5 megabytes. So we're gonna put this configuration in here. So after that I think we finished from dockerizing this application. Let me check the block. Yeah, so I think we finished, and now we can test this Docker Compose file to see if it's working or not. So basically we're gonna run the command Docker Compose up. I think we have an error. Validating. PHP backend is not allowed. Okay, give me a little time to see what the problem is. Okay, the problem basically is we didn't specify this services namespace in here. So all of this container will be a child of this namespace. So let's rerun the Docker Compose again, and now we're going to notice that our application will start building the containers and run them. In my case, I already have these containers built in my computer before, so it's happened very quick. In your case, it will take more time. So if you remember, if we go back to our architecture, Docker architecture, we're gonna see that our clients, in order to use the application, they need to access the Nginx web server. So for that, we need to bind this container port with a port in our local machine so we can access it. In this case, it's 80, but in this file, I specified this port from the environment variables, which is in my case 8888. So in order now to access my application, I need to access it from this port. So let's try it. Okay, it's not working. Maybe we have a problem. I can see. Oh yes, we have a problem. Yeah, the problem basically, I can't bind this port with my local computer because I already have a MySQL instance running on my computer. So to fix this problem, I need to change the ports in here to another one that is free in my computer and try again. So now I think, okay, this port is already taken. Let's do something random like 30,000. Okay, now the container is working. So we can test them from the same port. So as you see now, my application is working as expected. It's recommended to test the functionalities very well to check if there is no problem connecting with the database, changing or editing some stuff, upload some images, but I'm not gonna test that right now. We will test it when we deploy the application in the production environments, which will be in a VPS, a remote VPS that we're gonna provision from the AWS light sale. So going back to our blocks, to my blog, I think we finished from dockerizing the application. Now we're gonna deploy the application using Docker and Git. So the step one is to provision a VPS instance. As I said before, in my case, I will use the light sale. You can use any provider like Hostinger or DigitalOcean, but in my case, I will use the light sale. So I'm gonna create an instance for the operating system. We're gonna use the Ubuntu 24. For the configuration of our VPS, I recommend you to choose a 4 GB of memory at least, so we can run the Jenkins on it easily, and we can also build our containers in an easy way without struggling with performance issues. So let me check again. So Linux Ubuntu, a 4 GB memory. Okay, great. Now we can create our instance. So this instance is creating right now. It might take a little bit of time. Now after our instance have been created, we can access it using this button in here. This basically will open a new tab and will make a new SSH connection so we can control our VPS. So now we have our VPS connected to our machine using SSH. So we can go back to our blog to see what the next step is, to install Docker and Git. So we can install Docker using the mine documentation page. So there's a lot of ways to install Docker, but I'm gonna go with the package way. So I'm gonna download the bash, the bash script, and I'm gonna use it to install the Docker. Yes, this is the step. Script to install. And the script is here. You can get it from this link. You can copy this script and we can create a new script, new bash script. Let's call it my script.sh. We can pass all of the content we copied from the Docker documentation page. Now after we created our bash script, we need to give it the permission to run. So we're gonna use this command and then we're gonna run our script. So this script will install Docker for us. It might take a little bit of time, so we're gonna wait for it. Now after Docker installed successfully, we're going to go back to our blog to see what the next step, which is installing Git. We can install it basically using this command in here. You can copy it and use it. Okay, now Git is installed. So now we're gonna clone the repository of this code base, but before that let me do a quick push. Okay, great. Now let's clone the repository. No, sorry, not this. Let's clone the repository using this command. You can also clone the same repo as I'm using to learn how you can set up the CI/CD pipelines. You're gonna find all the resources that we're gonna create in this video. You're gonna find it in the repo, so you can use it in your own projects. So now we cloned the repository. Now we can go inside it. So we have all the code base files, as you see. So the next step is to set the permissions so we can use this folder. So we're gonna change the owner of this folder to the ubuntu user, which is the user we are using right now. So now the next step is to create an environment variable. So as you know, in PHP Laravel, in order to run your application, you need an environment variable that holds the configuration of your application, like the database connection, the app key, the app URL, and any other configuration that you might have. So we need to create this file. So let's go back to our VPS and let's create that file using the command sudo nano-prod.env, and we're gonna fill this file with this configuration. So we need to change the password in here, so you can put any password that will be the password to connect to your database. So let's do my pass, and we have also to change the app host and URL parameters. So basically you need to put here your VPS public IP address. You can get that from your provider. So in my case, this is the public IP address. I can copy it and use it. So let's post it here, and let's put it in here as well. We need also, in order to make this application running, we need application key. So this is basically a secret to encrypt, to do encryption in the Laravel framework. So you can basically get a secret from a website that generates secrets for the PHP Laravel. So Laravel app key generator, we have this website, for example, that generates random secrets using the base 64. So we can get that and put it into our environment variables. Great. Now we created our environment variable. Let's see what's the next step. So the next step is to build the containers using this command that use the docker compose and specify the environment variable that we created earlier. So we're gonna copy this and run it in our VPS. So now our VPS will start to build the containers. It might take a long time in the first time you apply this command. So it basically will download the layers and start to build our project from scratch. Okay, now the containers are built successfully. It took around 5 minutes in order to build these containers, but it will take only a long time in the first time you do. But when we rerun the same script another time, it will take less time because all the layers are downloaded and some layers are even cached and never run again. So now let's go back to my blog to see. So if we now access our public IP address from here, we're gonna notice that we have our application running as I think, but it will be a problem. So basically Laravel will give us an error telling us that some tables are not found, because basically we need to run migrations. So that's why in the blog we have this step of migration. So we can do it basically by running this command. If you run your own Docker containers, you might name them different name than I have used in here. So be sure always to, if you use these commands from my blog, to replace these names before putting them in your computer. So now if we go back to our public IP address and refresh the page, now we have our application running successfully. So as you see, we don't have any data because this is a new brand database. It's not containing any informations, any TV shows, any episodes, any actors. So it doesn't have any user. So we can't test this application very well. So for that, I'm going to do something. We're going to try to connect to the database inside that container and fill it with some data I already have in my computer in order to test this application if it's working well, because like this I don't have any data to work with to test my application. So if you go back to our Docker Compose file, we're gonna notice that I binded the port 30,000 with 3,306. So basically we can access the database inside the container from this port. So we can access the database from this public IP address with the port 30,000. But before that, we have to configure some security stuff, which is the port forwarding. So you can access the networking panel and add a rule which is accept the connection from the port 30,000. So let's create it, and we can use a client like the MySQL Workbench to connect to our remote database. So basically here we need to specify the public IP address, which is this. We're gonna specify the user, we're gonna connect as root, and here we're gonna put the password which is we specified in the environment variable. In my case it was my pass, I believe. So let's try to connect. It's taking more time than it should be. Maybe there's a problem. Maybe I didn't specify the ports. Yeah, that's the problem. Let me try another time. So here we need the port 30,000. Here we have our public IP address, and here the password. So let's try now. Okay, and now it's worked. So what I'm going to do is import some seed data to this server, this MySQL instance. So basically we can test our application. I have a dump folder in here that contains some basic data that we can use, and let's start to import. So basically now I'm filling the database in the VPS with dump data I have in my local computer. So as you see, all the tables now are imported with their data, with the user, with the passwords, with all the things. It's taking its time. Okay, now the importing have finished. We can go back to our public IP address and refresh the page. We're gonna notice that there is the data, but there's the data, but the images are not exist. And why that? Because if you remember, in the first place when we did our architecture, there's two volumes, one volume for the database, the second volume for the static files. We imported the database files or the data files, but the static files or the images, we did not import them. So for that we have the metadata but without images. So to test the application, I'm gonna do access the administrator panel and test if we can upload images to our application. So basic as that. So let's go to the shows and let's try to delete a show, so we test if the database working correctly. So the show have been deleted successfully. Let's edit a previous show and change its picture. Let's do this. Let's save, and now let's go back to the home page and see if the image is there as we do. So as you see, the image is served successfully. So now we are sure that our application working well, our volume set up as well. So let's go to the next step according to my blog. So we finished the deployments. I think now we're gonna go to the CI/CD implementations. So now we're gonna see the requirement of the CI/CD pipelines. So the first thing we're gonna talk about the continuous integration. So basically we need to integrate our new code through our GitHub repository and test it, then apply it to our code base on the VPS and run the unit testing. And we have also the continuous deployment, so we can see the new change that we did on our application, and we can access it after each we can access the new update after each git commit. So this is basically an architecture that we're gonna work with to implement this CI/CD pipelines. So the first thing, we have our local computer, we have the code base on it, we're gonna push to a production branch. So after that, the GitHub will send a webhook to our Jenkins that we're going to install it on our VPS. The Jenkins will work on the port 8080. So after the webhook arrives to the Jenkins will run the deployment job and update all the containers with the new changes in our repository. And of course our clients will still have the access to our Nginx web server to access our application. So the first thing we're going to do is install Jenkins. In order to do that, we're gonna follow the Jenkins installation documentation in the official documentation page in Jenkins. So this is the script that we're gonna run. So basically we're gonna run this in our VPS. So let's run this. Okay, I lost connection. Let's refresh the page. Let's pass this, enter. Okay, good. So after we install Jenkins, now we need to install the GRE, the Java Runtime Environment. I think there is some steps in here to install it. Oh, this is Docker. Oh, okay. Here is how we can install the GRE 17 in order to run Jenkins, because Jenkins rely on Java. So now after Java installed, we can check if it's installed really by running the command java-version. So as you see, the Java now is running on my computer, running on my VPS. Now we can start the Jenkins server by running the commands systemctl start Jenkins. Okay, now the Jenkins server must be accessible from the port 8080, but before we access it, make sure that you have the port 8080 in your port forwarding configuration. So now, as you see, Jenkins installed on our local machine. So the first thing we're going to do is to put the administrator password that we can get from this path in our VPS. So we can take its contents using the cat command. So this is the password. You can copy it and put it in here. Okay, now we can install the suggested plugins, which contain all the plugins we will need to implement this CI/CD pipeline. So this will take some time. Going back to my blog, I think the next step after installing Jenkins is to connect Jenkins to GitHub. So basically we will create a production branch in our GitHub repository. I already have this branch created, so I don't need to do to create it another time. We need also the GitHub integration plugin in Jenkins to be installed, but since we installed the suggested plugins, I think the Git plugin will be installed as well. And after that, we're gonna create a new pipeline which will create our CI/CD pipeline. So after that, we need to create this Jenkins file in our code base. So let me copy it and create it while the Jenkins is installing the plugins. So we're gonna create a folder called Jenkins file like this, and we're gonna put this content. So basically this is the configuration of our pipeline that we're gonna create on Jenkins. So the first thing, we have this stage, which is the build Docker images. So this basically will run the Docker compose using the environment variable, which is the production.environment, and we will do this parameter to ensure if the containers are running. We're going to remove them and recreate another ones to update them with the new content. And if the build succeeded, we're gonna print this message. If it's failed, we're gonna print this. So this is a basic pipeline. We just gonna do the same thing we did earlier, but we're gonna automate it each time we're gonna push to our branch. So going back to the Jenkins installation, now we're gonna specify the first admin user. Okay, now Jenkins is set up and installed successfully. So we're gonna create a new pipeline. Let's call it my pipe. Okay, now we're gonna configure this pipe. The first thing, we're gonna check this GitHub project and provide the Jenkins with our Git repo link. I think the link is in here somewhere. Authorization. Let me search. Okay, this is the repo. So this is the link of our project. We're gonna also check this GitHub hook trigger. So we configure this pipeline to run every time the GitHub will send a webhook to this Jenkins instance. In the definition script, we can use this template, which is basically will connect to our GitHub automatically. We need only to specify the repo URL, and we need to specify the branch that we will be listening to. In this case, it's going to be the production branch. And here is the script path. This is basically where is the file that we're going to run every time we have a change in our branch, which is the file we created earlier, which is the Jenkins file. So here we need to specify the Jenkins file that will be run every time we push a change in the production branch. So let's save. So great. Now according to my block, if we go back to the point we were, so I think in here, yeah, we created the Jenkins file, and here we need to set up the new pipeline, configure Jenkins to trigger build on push to production. So basically we need to go to the GitHub, our GitHub repo, and configure a webhook. So every time we push something to the production branch, it will invoke the Jenkins, so it will start the deployment job. So this is the URL. The URL will be basically, if I go back, I don't remember. Let me ask ChatGPT about the link that we need to do. Okay, this is the link. We're gonna add it in here, and here we're gonna replace the Jenkins URL with our VPS public IP address. Like this. Okay, great. We need to specify the port and add a webhook. So now when we gonna push a change into the production branch, it should invoke a job, the deployment job that we have, or basically it should run this Jenkins file that we have in here. So let's try to push something to the production branch. So first we're gonna push to the master branch, then we're gonna check out to the production branch and merge with the master branch. So git checkout prod, then git merge with master, then git push. So now after we pushed to the production branch, we must get a notification in here. Yeah, as you see, the build have run, but we have an error. So let's see. Enable to find the Jenkins file. Maybe we need to do a capital G in here, so our file will be recognized by Jenkins. Let me rename this. Okay, let's push again. Git and okay, we need to do a change maybe. Okay, up. So now I think the deployment job will find our Jenkins file and run. So let's go back to the pipeline and see. It's took sometimes. Okay, maybe we have a problem. Okay, it should appear in any moment. Maybe we have a problem. Maybe there is something in here. Let me commit manually. So there was a glitch in this pipe. It wasn't working. I didn't know the cause why. So I removed the pipeline and created another one, and this time it's working well. So let's see the console output. As you see, this time the Jenkins file is running, but we had a problem, I think, in here. Couldn't find the environment variable. So because of Jenkins, when clone a repository, it's clone it into this folder, which does not have a production.environment variable. So we have to recreate that production environment variable in order to make this job run successfully. So let's go back to our VPS. Let's refresh the page. So the first thing, we're gonna cd or change directory to this folder. Then we're gonna create a new production.environment variable file, and we're gonna use the same template we used earlier. I think in here, yes. Gonna paste it. Gonna do a password in here. We're going to change also the app host with our public IP address. Let me copy the public IP address. Okay. And also need another app key. You can get another one from the same website. And now, after we have our production.environment variable in the workspace, let's schedule a new build. So we have a permission denied error. So first let's go back to our blog to see if there is any instructions. So I think, alright, there's an instruction for creating the production.environment file, and we have another instruction to give Jenkins permission to run Docker. So that's the reason why we get this error, because Docker Jenkins does not have the permission to run Docker. In order to give it the permission, we need to do this command. So the first thing, we're gonna add Jenkins to the Docker group, and then we're gonna restart Jenkins. So let's restart Jenkins and see. Okay, now let's go back to our pipe. Let's refresh the page. It's going to ask us to re-login because we started the Jenkins server. So now we're gonna invoke the build job again and see if it will run successfully or not. So here's the console output. I think now the Jenkins can run Docker without any problem. As you see, our containers is building. So before you run the Jenkins, always make sure you don't have the previous Docker containers running. So this is the case I have in here, but I think it's not going to be a problem, because if you remember in the Jenkins file we did this argument which force recreate. So basically it will stop those containers and create another one. So we have a problem, I think, in here. The container is already in use by container. Okay, we have a problem. Error response. So okay, I don't know why we have this error. So basically it will be related to these containers. So let's put them down. So if I remember, these containers, okay, here is our the project that we cloned earlier when we tried to deploy the application. So basically we're gonna run the Docker, let's run the sudo first, Docker compose down. So we're gonna shut down those containers before we're running a new build job in the Jenkins. So it will not be a conflict between these containers and the containers that need to be run in the Jenkins. So you're gonna notice that the application we deployed earlier will not be accessible by now because we shut down the containers. So as you see, the application is not responding. So let's rerun the build job to see if it's going to work now. Okay, as you see now, the deployment done successfully, and I think if we go back to our public IP address, we will have access to our application. But as you see, we need to do migrations first, or maybe not. Oh yes, we need migrations. So let's go back to our blog here, how we can do the migration. Let's copy this. And let's go back to our VPS. Let's run this. We need a sudo to run this. So now we are migrating our database. Great. Let's refresh. Okay, now the application is running. We can do the same thing as we did earlier. We can see the database of these containers as well to test them, but we're not gonna do this because I'm sure it's going to work, but I don't want to waste more time in this video. So basically we're gonna go to the next step. So the next step is to integrate the unit testing into our CI/CD pipeline. So the first thing we need to do is to create a new Docker Compose file. So this file will be only for testing, to create an environment for testing. So let's create this Docker Compose file. So this file will be as the same as the previous one with some changes. So the first change is we don't need a web server anymore, because this environment will be just for testing. We don't need to serve this application for any clients. So in this case we don't need a web server. We have also only the database and the backend. And also you're gonna notice that we removed the volumes. So in this case we don't need volume because we don't need the data consistency. So it's not a problem if the data is wasted, because this environment is only to run the unit testing and see if they are succeeded or not. So the next step after creating this Docker Compose, we need to create a new Docker file, and it will be also for testing. But for this Docker file, it will be exactly the same as the previous one with one small change. So we're gonna copy this and put it in here. So the only change will be, according to my blog, is in the composer dependencies installing. So we're not gonna install only the production dependencies, but we're gonna also install the dependencies that we're gonna use to run the testing. So in order to achieve that, we need to remove this parameter which is makes the composer not install all the dependencies, only the production one, but for the development one that contains the testing libraries, it will not be included in this case. So for that, we're gonna remove this parameter in this docker file.test. And let's go to the next step. We're gonna update the Jenkins file. So if you remember, in the Jenkins file we had only one stage that built our Docker images and run them in our VPS. But now we need another stage, which is the testing stage. We're gonna copy this and put it in here. So basically this stage will run our application in a testing environment to run the unit testing. And after that, if the testing is succeed, we're gonna proceed to the production environment and run the container in the production environment. Otherwise the script will throw an error and stop. So here is the script. The first thing, we're gonna run the Docker Compose to run the new file we created with the same environment's variable file. And then we have this algorithm. So this basically will try to invoke a migration request to migrate the database, because we can't migrate the database. We can test our application without running the migrations. But the problem is the container of the database is not ready to take connections directly after the container is created. takes sometimes. In my case it was around 30 seconds. So to solve this problem, I implemented this algorithm to try to do a migration every 10 seconds until it succeeds, or we cross the max retries, which is 10. So if we run this command 10 times and it fails in each time, we're gonna throw an error and stop the building, because it will be some unexpected error. But unless we don't reach the max retries, we can rerun the migration until it works. So after that, we're gonna run the unit testing using the PHP artisan test in the test TV backend container. So that will basically run the unit testing in our application, and if it succeeds, it will build the images, the container in the production environment. Otherwise it will stop the script. We need also another change, as I believe, yes, this piece of code which will basically tell Jenkins to, every time it run this script, to stop the testing containers that we used in here, because we don't need them. We need them only for testing, so there is no need for them to be running. So we're going to stop them in every time we run this job. So let's save this and let's push to the production branch and see if this is working. So here is the job started. You can see the console output. So we run the Docker Compose for the testing environment. As you see, now it's going to build the project and run the unit testing. So as you see in here, after the containers are built, as you see, we run the migration command, but as you see, there's an error, a connection refused, because the database is not yet ready for take connections. We're gonna sleep for 10 seconds and retry, and another time it's not ready for take connection. But as you see, in the third time, the command the command is worked and the database is migrated. And in here we run the PHP artisan test, which will run the unit testing, and as you see, all the tests have been succeeded. So now we're gonna proceed to the production environment. We're gonna run the Docker Compose for the production environment, and we're gonna update our containers as we used to do earlier. So I think it's almost finished. So yeah, so now we're gonna test this environment and see if really we can deploy our changes and run the unit testing. So we're gonna do like a demonstration for this pipeline. So the first thing I'm gonna try to do is to change something that we can see. For example, we're gonna change this header. Let me look for its file. So it will be in resources, views, index. So here is, I think, the header, or let's change this piece of text. So let's add a 3 points after recommended choice in here. So after that, I'm gonna push to the production branch, and I expect after the build job is done to see the new changes in my website automatically. So let's see what's going to happen. So the first thing I have, the job is here. So we're gonna wait for it until it's finished, and then we're gonna check if our websites will be updated with the new content. Now, after the build job have been completed, let's go to access our website and see if the changes are published. And as you see, we have these 3 points that demonstrate that our CI/CD pipeline is working. We're gonna do another test, which testing the failure case. So we're gonna simulate a unit test failure and see if the change will be published or not. So the first thing we're gonna do is go to the unit testing, and for this test, for example, that the test that true is true, what we're going to do is we're gonna change this to false. So basically this test should fail, and the meanwhile I'm gonna change the text in here to make it as it was, and I'm going to see if the pipeline will accept this change or not, because as you see our unit testing will not going to succeed. So let's do another push to the production branch. Now let's check if the job have been started. Okay, as you see the job is started, and let's wait for it and see the result. And now as you see, after the testing, containers have been created, and now the script is trying to migrate the database. Let's wait for the next try. Okay, now the database is migrated successfully. Now for the test, as you see, we have a unit test that failed, which is the test that we edited earlier. So after a test is failed, the deployment job will exit and will not publish our changes. And to make sure of that, let's go back to our website and refresh, and you're gonna notice that the points I removed are not removed from here. So our changes are not published because of a unit testing which is not succeed. So this was basically a basic implementation for a CI/CD pipeline for the PHP and Laravel framework. So I hope it was useful for you. So thank you for your attention, and see you in another time.